Welcome everyone to the CK-12 Certified Educator Program. We're so delighted that you've all joined us today for our session called CK-12 Simulations and PLIX Interactives. We're coming to you live from the CK-12 offices in Palo Alto, California, in the heart of Silicon Valley. I'm Lindsay, a member of the CK-12 team, and I'm going to be moderating today's webinar. Before I introduce you to my coworkers, Katie and Sonia, who will be demonstrating our PLIX and simulations today, let's make sure everybody's comfortable with the windows. We start with this every time, mainly because oftentimes in the community chat window, messages get sent to only the panelists. So the biggest reminder here is that as you guys are introducing yourselves and talking about where you're from and what subjects you teach, please make sure to change it from all panelists to all panelists and attendees so that everybody can see your messages. And then the Q&A window is where we would like you to ask any questions that you would want formally answered during the webinar by our presenters or by our CK-12 team members, who will be also answering some questions via text. If you have any technical issues during our broadcast, just let us know in either one of these windows. So we are getting toward the end of this Certified Educator program. We're on the last 3 days. As you guys know, the requirements for this program is that you attend 7 live sessions, or if you have to miss one, you can substitute one of those sessions for a recorded video. You do have to complete all of the assignments to go with these 7 sessions. We have records at this point of your attendance in the webinars that we then can compare with the assignments. And once you guys hit the maximizing learning sessions, we had 1 of them in June, and then we have 1 on Wednesday and 1 on Thursday. That's when you're going to complete the final assignment, that final form where you request your certification. And there's a lot of information on that form that you'll fill out to tell us what you completed this summer and also give us, kind of some survey information about how we did with the program. So if you have any questions about the program, make sure to ask them as we go through the webinar today. But we're hoping that you guys are all on pace and you're going to be part of this CK-12 certified group here before long. So at this time, I'm going to go ahead and introduce you to my colleague, Katie, who's going to begin our presentation.
Thanks, Lindsay, and thank you to everyone who joined us today for today's session on CK-12 Simulations and PLIX Interactives. Today we are going to highlight our Science and Math PLIX, which stands for Play, Learn, Interact, Explore. This tool allows users to animate ideas through simple interactions. Also, we will be discussing our science simulations, which enable learners to discover the scientific principles that govern a real-world setting in a fun and interactive way. Before we get into the core content of the webinar, we would like to find out a little bit more about your familiarity with these interactives. You'll see a poll here in a few seconds that will prompt you to respond to a question. So here's the question. How familiar are you with CK-12 simulations and PLIX interactives? You can select all answer choices that apply. I am new to them. I use PLIX occasionally. I use simulations occasionally. I use PLIX frequently. I use simulations frequently. I'll pause for a few seconds to let you finish answering this poll. Remember, please select all that apply to you. All right, we'll give you just a few more seconds here. Let you finish answering this poll. Okay, awesome. Thank you so much. All right, so it looks like a lot of you are new to our interactives, so this is a great time for us to tell you all about them. All right, so let's move and discuss PLIX. CK-12 PLIX. In this first section of the webinar, I'll help you to get to know PLIX. We'll go over what a PLIX is, the structure of a PLIX, and how to find a PLIX. Plus, we'll talk about ways to use PLIX in and outside class, to differentiate instruction, and to start a conversation. Our goal is to get you ready to try a PLIX in your class, even in the first week of the school year. So, PLIX stands for Play, Learn, Interact, Explore. It is a visual learning modality that allows users to animate ideas in a concept through simple interactions. We have over 1,130 interactives that span both math and science concepts and can be filtered by subject, keyword, concept, or standards. Also, PLIX, like everything else offered by CK-12, is free to all users. All you have to do is sign into CK-12 to access them. So after you've opened up a PLIX, the first thing you do is read the description on the left. The description explains what the interactive is about and provides directions on how to interact with it. Next, use the interactive by following the prompt and the instructions. In the interactive, you can explore the concept. If you need to start over, there's a refresh button at the bottom that you can use. After you've used the interactive, click the challenge button below the description. This opens up the challenge questions. The questions often build upon one another to help students reach a deeper understanding of a concept. The final question is a discussion question that you can use for a class conversation. This is actually a great place to think about differentiating learning by having students try the first few questions or work their way through to the higher level thinking and discussion questions. As a side note, anytime that we bring up a teaching strategy, we'll post a brief description in the chat window so you can see it there. We'll also send you a full list as a follow-up to this webinar. All right, so along the toolbar at the top of a PLIX, you'll see that there are even more features. We will discuss more of these features as we go, and now let's dive into a PLIX. Okay, so this PLIX is about lunar favorites, one of my favorites. The description of this PLIX includes a prompt on how to interact with it. Notice that it says to drag the red point. Moving the red point changes the phases of the moon in accordance with the labels on the slider. At the top right of this PLIX is an orange button to assign to class. You can assign PLIX to students in a CK-12 class group by clicking on that button. If you want to learn more about assignments, feel free to ask us in the Q&A window or check out our webinar Groups and Practice 101. You can see the recordings of our recent sessions on our program page. All right, so let's look at another PLIX for a second. Before we explore the PLIX itself, you can see in the top right the options to give feedback and adjust the size of the text by clicking the icons in the upper right corner of the screen. We do read your feedback, so please share any of your thoughts with us. You'll notice that this PLIX about rules for dilation has the same description and prompt area, the simple interaction and challenge questions. This PLIX uses two of the most frequently seen question types, multiple choice and select all that apply. If a student is struggling with a question, they can often find hints to help answer the questions. So there's a couple of hints on this one. Notice that if you get a question wrong, you'll see the option to show the correct answer. Once again, this is a learning, not an assessment tool. So students will be able to get immediate feedback and guidance when they attempt a question. Students can also use the Learn More option to read more about the matching concept through this little pop-up screen and gain a better understanding of it. Encouraging students who are struggling to access these resources is another great way to personalize and support student learning. Okay, so now that you've seen two PLIX, you may be wondering where you can get your hands on them. You can access our PLIX through the website on any computer or tablet with a screen size of 7 inches or larger, or with a resolution of 1024 by 768 or larger. You can also change the resolution settings on your device, and you can access our PLIX through the website on any computer that's 9 inches or larger. It usually has a pretty good load there. You can also use the search bar to find content and modalities, including PLIX, or you could open PLIX from within any concept. So you can access PLIX through the circular PLIX icon on the home page. Alternatively, you can jump directly to the PLIX browse page using www.ck12.org/PLIX. Let's see what that looks like. Once on the Browse page, you have a few options. Remember to sign in if you haven't, and then you can choose your branches. This will help filter your PLIX according to areas you're interested in teaching. If you've done this and you want to update those branches, you could click on Change Branches. In addition to searching on the main site, you can search within the PLIX Browse page. Here you can search for a title, concept, or even CCSS or NGSS standard. You can find PLIX in all branches of math and science. To achieve this depth of coverage, we've developed some really diverse PLIX. Some PLIX are exploratory based, while others check for student understanding. Some PLIX are abstract, and others are based in the real world. Let's dive into a few examples. All right, so these exploration-based PLIX are sandboxes in which a student can play around and experiment with an idea. In the distance between 2 points taxicab distance PLIX, students explore 2 different ways to find distance between 2 locations. In the Ohm's law PLIX, students explore how Ohm's law affects the current in a circuit. A great teaching strategy would be to have students explore a PLIX and then share their different experiences and what they learned with each other. In some PLIX, like these, students can get feedback to check their understanding of a concept. The structure of water PLIX allows students to rotate water molecules to form hydrogen bonds. In the law of cosines PLIX, students find the missing side lengths of the triangles using law of cosines. These PLIX could be used as a review of a concept so students could see how well they understand a concept before an assessment. In many PLIX, students can manipulate graphs, diagrams, or variables. In this sine and cosine PLIX, students can explore how the values of trig functions relate to a given angle. In the refraction band gap PLIX, users change the band gap of a substance to see if a photon can fit through. As a lesson, you could have students screenshot a few different states for a graph or set of variables and explain what changed and how the change affected the graph or situation. Some PLIX use real-world context to teach math and science concepts. In the Rainforest Map Quest PLIX, students can locate villages on a map using a scale. In the Rate of Dissolving Sugar PLIX, students observe what happens to a sugar cube in tea as the temperature changes. For these real-world PLIX, try having students brainstorm other applications of a particular concept, or even design their own PLIX to address a concept. So, as you've seen throughout these PLIX, there are a number of different ways to have students work with and use a PLIX. In class, you could use them as a warm-up exit pass or to explore a concept. At home, students can use them for homework assignment, or they can post answers to PLIX questions on the CK-12 site. You can use them to differentiate instruction using the challenge questions, learn more, and explorations. And you can use them to foster conversation. The last question of every PLIX is a discussion question, and some of these questions lead to the PLIX Corner. So I've mentioned PLIX Corner a couple of times now. So let's talk about what it is and how to find it. The PLIX Cafe is a place where you can ask, help, and share with others. Just click the link to the cafe at the top of the CK-12 homepage to get there. We're going to enter PLIX Corner, where users answer intriguing PLIX discussion questions. All right, here's a great example of a discussion in PLIX Corner. The PLIX math question of the week was from Sets and Symbols, Size of Infinite Sets PLIX. You can assign the PLIX featured in a PLIX Corner post and have your students join this conversation and discuss their ideas with classmates and other students across the world. One of the standards of mathematical practice is construct viable arguments and critique the reasoning of others. The PLIX Corner is a great place for students to discuss their reasoning about a topic. As participants of this webinar, you get an exclusive sneak peek at a future version of the CK-12 Geometry Concepts book. CK-12 is enhancing the book by adding interactives for students to explore concepts by hand, rather than just looking at diagrams. This section is on triangle sum theorem. In the first interactive, students can explore the dimensions and angles formed by the Bermuda Triangle. Next, we're going to look at a class activity. Let's see, here it is, where students tear off the angles of a triangle and align them to see that they add to 180 degrees. This activity can be followed up with an interactive to summarize the experience. And the last interactive here introduces a 2-column proof of triangle sum theorem. Yeah, so it's pretty cool. Lots of interactives in the book. If you are interested in exploring a preview of the new interactive filled geometry concepts book before it's published, contact interactives@ck12.org. All right, have fun exploring our new interactives. Okay, so I've told you a lot about PLIX. Now it's your turn to find a PLIX that you could use in your classroom. Push escape to escape from the Zoom window, open up your internet browser, and go to CK12.org. For those of you staying on the Zoom window, you can watch me find PLIX on the CK12 site. All right, so I'm going to open this up. All right, so here we are at CK12.org, and time for your first challenge. Navigate from the CK12 homepage to the PLIX browse page. If it's your first time on the PLIX browse page, or if you're not signed into CK12, you will be prompted with a tutorial on how to use PLIX. All right, so we go down here, and here's the browse page. We open it up, and you can see all the different branches and everything. All right, now let's go back to the CK12 homepage and try to find a PLIX within a concept page. As a geometry teacher, I would often start the school year off reviewing points in the coordinate plane. So the second challenge, find the PLIX related to the concept of points in the coordinate plane. So after you return to the CK12 homepage, ck12.org, in the search bar at the top of the page, type in points in the coordinate plane. Oops, clicked on the wrong one there. Let me try again. So points in the coordinate plane, there we go. All right, so the biggest search that appears at the top of the list says points in the coordinate plane and directs me to the concept page. I'm going to click on it. At the top of the page in featured content, I should see a PLIX with a title that begins with map of the town. Click on that. And this is a nice PLIX that allows students to explore the fundamentals of plotting points on a coordinate plane by building out a map of locations in a small town. All right. So with that, this might be a good time to stop and see what questions we have coming in about PLIX before we move on to the second half of this webinar, where Sonia discusses simulations. Please join us back in your Zoom window or participate in the chat and Q&A.
All right, Katie, we have a question, several questions actually, about checking student accuracy, about if the PLIX is an assessment tool. So if we assign a PLIX, are we able to see student accuracy, or do we simply see that a student has accessed the content?
So when assigning PLIX, you can see a student's progress through the questions and see that they completed all the questions, but you actually don't get to see their accuracy. And that's by design, because we want this to be a safe little learning environment where students feel the sense of being able to play and explore. And the assessment comes from completion rather than assessing whether they got it right or wrong in the process of learning the PLIX, or learning the concept that the PLIX is teaching.
We had several questions come in about integrations with learning management systems. And so our answer to that is we had a couple of like, do you integrate with Edmodo? How are PLIX assigned? And you can always share the URL to a PLIX with another platform. That's the best way to do it right now. There's really not an available way to integrate with an assignment on most LMSs. So your URL to the PLIX, however you would blast out a URL, is currently your best option for integrating with an LMS. A question for you, Katie, on the PLIX corner. How do questions appear? What's the organization of the PLIX corner? Are they randomized? Can they search?
Yeah, let's take a look at PLIX corner real quick. So going to CK-12.org, and we could click on the cafe, go over to PLIX corner, and you'll notice that we have math and science PLIX questions of the week. So this one is the math PLIX of the week, and then here's science PLIX of the week. And so each week we feature 2 different PLIX that we select, and we have a little question that goes along with it here in bold at the top. People can add their answers at the bottom. This one just was posted yesterday and hasn't been answered yet. We also have users post questions about PLIX or related to PLIX, and other users will answer them or will answer them. Like I showed you, the discussion questions sometimes links to the PLIX corner. So you can, after you go through a PLIX, you click on that link and then you can actually answer the question here.
How about this question on customizing? Since so much on our site's customizable, is there any way to customize a PLIX, or what kind of activities could get people more involved in the PLIX creation process?
So at this moment, users are not customizing PLIX. However, if you have an idea for a PLIX that you'd like to use in your classroom, just email interactives@ck12.org, and we can work with you to actually build that PLIX. Like I showed you with the new interactive geometry book, we are going to be integrating PLIX-like interactives into our books coming up soon. And just like any other CK-12 book, those books are customizable. In addition to geometry, we're also looking at launching some other interactive math books as well, including algebra and a little later on probability and statistics and calculus.
Could you go over the requirements one more time for screen sizes? A user just asked if this can be done via cell phone, which we know isn't an option, but what are the recommended screen sizes? Probably have to get to more of a tablet, iPad before this starts working for the students.
Yeah, sure. So for a PLIX to load best, it would have to be on a screen of 7 inches or larger, or with a resolution of 1024 by 768 or higher. Oftentimes the Mac devices, they're 7 inches or larger, work really well. Sometimes devices like Nexus 7 say it may load, but it may not be optimized unless it has that resolution of 1024 by 768. You can change the resolution settings on your device sometimes, or you could switch to a different device.
Okay. We still have a few open questions about PLIX, which our team might be getting to via text, but I think I want to start getting on to the second part of our Interactives webinar, which is about simulations. So I'm going to steal the screen back for a moment, and then we're going to bring on my colleague Sonia, who is the simulations expert, and she's going to share all of her knowledge with you. So I think we're ready for you, Sonia.
All right, thank you so much, Lindsay, for inviting me to participate in this webinar, and thank you all for joining. I'm really delighted to be here with you this morning to discuss CK-12's interactive simulations. I'm going to start by focusing on our collection of 120 simulations, which we at CK-12 lovingly refer to as SIMs. and show you how to navigate the Sims browse page, similar to what Katie did, and how to search for a particular sim. I'll then help to familiarize you with the general structure of the Sims and highlight the many embedded Sim features and resources. I'll share some ideas I have for using the Sims as an instructional tool in class or at home to differentiate instruction and to dispel those common science misconceptions. Throughout the presentation, we'll continue to post the planning and teaching strategies in the chat window, so be sure to have that window open and kind of be referencing it. My main goal, like Katie's, is that by the end of this webinar, you feel excited and equipped to use CK-12 simulations in your class this upcoming school year. Pick one sim and experiment with it, even as early as that first week of school. All right, so this is actually a picture from my class 3 years ago. I used to be a classroom physics teacher, and sadly, I spent my entire lunch period drawing this image for my students, just trying any way to relate the law of reflection with what they see in a mirror. Thankfully, advancements in computer programming have led to something that was not available to me at this time: the ability to overlay a realistic physical scene with their scientific and mathematical descriptions in a much more compelling way. Here is an example of a CK-12 interactive simulation. This is the prom night sim, a result of the beautiful collaboration between science teachers, animators, and software developers at CK-12. The prom night sim begins with an intriguing question that you see here, and then it advances through an introductory video that explains the basic concepts and poses further questions to get students to think about the underlying physics in the real-world scenario. Much better than my classroom drawing, and now maybe, you know, I could have eaten lunch. All right, so then you're invited to go into the sim, and we call the next scene the Sandbox because it's meant for users to play around and just discover new things. In this interactive environment, you'll always find sliders for certain physical variables, and oftentimes you will find graphs, or in this case, responsive animations, that illustrate the relationship between these variables. The next scene poses 3 questions that can be answered by adjusting the sliders in a certain way. So we call them slider-based questions. And then every simulation ends in a final scene with 4 more real-world questions that invite the students to think about the applications of the underlying concepts in a different physical situation to promote their continued learning. So now hopefully you're really excited about accessing the Sims, and there's many ways to access the Sims from on the CK-12 website, including that simulations icon on the home page. You can see there, it kind of has a little roller coaster icon on the bottom left. And also the web address, I want to share with you a little shortcut. It's www.ck12.org/sims. And this is you know, a simple link that you can use or share with your colleagues, students, post on your class websites that will bring students directly to the Sims browse page. Our Sims, like everything else offered by CK-12, are free to all users. You simply have to sign in or join in the top right there to access the simulations beyond your first sample. Okay, so let's make our way to the Sims browse page. Here we are on the Sims browse page, and our collection of Sims are currently divided into 2 branches. We have our physics simulations and our chemistry simulations. So you can see those 2 tabs there on the top left. Right now we're looking at the physics tab, and here you'll have access to over 100 simulations that animate real-world settings that are really hard to replicate in the classroom. That's kind of one of our themes. Here's just the first row that you'll find on the Sims browse page, and they actually feature 3 of my favorite Sims. First, on the left-hand side there, you'll see the Journey to Mars sim. That allows students to explore why trips to Mars happen only during certain launch windows. In the middle, you'll have the violin sim, and it poses this really fun question. Why does a violin sound different from a guitar? And then on the right, you'll see probably my most favorite sim, the rose-colored glasses sim. And this allows students to explore how we perceive color by changing the light and color in a luxury car showroom. Really fun. And like I said before, they're all real-world settings, hard to replicate in the classroom. So although these sims are formally labeled physics, their topical coverage is broad. And we do have sims that relate to concepts regarding physical science, earth science, astronomy, and math. So even if you're not a physics teacher, I encourage you to visit the CK-12 Sims browse page at www.ck12.org/sims. And I'm confident you can find something for your course and level. Even you math teachers, and I'll have some sims to share with you at the end of the presentation. Another exciting announcement is that we offer a free CK-12 Physics Simulations app for your iOS and Android tablet devices. By clicking on either of the two icons you can see there, the app icons in the top left, you and your students can easily download the app for free at the App Store or the Google Play Store today. And I'd like to highlight a few things about the app. It's only for tablet devices. So all of our sims, whether accessed online or via the app, require a 9-inch screen or larger. So it's important to note that the sims do not work on smartphones, although the majority of CK-12 resources do work on smartphones, and everything works on our website. The exciting thing about the app is that it allows you and your students to download individual sims to your tablet for offline use. So say goodbye to wasting precious class time loading software, guiding students through multiple clicks to access a simulation. I remember doing that in my classroom. All of our CK-12 simulations are HTML5 based and can be launched on our website or via the app with just one click. Just imagine a simple homework assignment involves asking your students to download a particular sim to their tablet device the night before so that when prompted in class, they can all launch the sim quickly and easily without any threat of Wi-Fi or loading issues interrupting the lesson. We've worked really hard to ensure that you never lose a learning moment in your classroom. So I hope that after the webinar that you go and download the app and explore with, downloading the individual sims for offline use. I think you'll be really excited about this. Okay, so going back to the Sims browse page, the second tab is going to give you access to 13 recently released chemistry simulations that are still in the beta stage of development. So you'll see the beginning of the full structure that you see for the Sims. Now, these chemistry simulations still all take place in really compelling, fun, real-world settings and aim to provide the microscopic explanations for macroscopic observations of the world around us. So I hope you explore and experiment with using these newly released Sims in your classroom, and please provide us with your feedback on what you think and how it goes. So going back to the physics simulation browse page, and I scroll down a bit to the next row of sims. So here on the left, we have the airplane sim, and it allows students to manipulate the forces of flight. In the middle, we have the Cassegrain telescope sim, which explores how a telescope collects and magnifies light. And then on the right, the prom night sim, which I briefly showed you earlier, that kind of illustrates the law of reflection. So there are many ways to explore our sim collection and to find a sim for your particular class. So you can simply scroll down as I did. You can also type in keywords in the search bar. So you'll see the search bar highlighted here. And you can just type in any keywords and a collection of sims will appear. You can also sift through the filters on the left there. So we give you the option to filter the sims by concept or NGSS Standards, which is very useful for schools or districts that are trying to become standards aligned. These concepts and standards are also listed under each simulation. So you'll see it highlighted there, concepts and standards. All right, so in addition to these filters, I'd also like to highlight that there is a worksheet and it's linked under each sim. So when you click on worksheet, what's going to pop up is a PDF version of our sim, and it's easily downloaded. There are a variety of ways that these worksheets can be used, but I think it's most important to note that all of the embedded features and the content in the sims are accessible in worksheet format here. So if internet's an issue at your school, or you'd like a handout that provide a guide to kind of help guide students as they use the sim, or if your students just simply respond better to turning something in, these worksheet resources are currently available for all of our physics sims, and the chem sim worksheets will be coming down the road. So please check those out. Okay, so now that we're a little bit more familiar with how to navigate that Sims browse page, filter, see the standards, and access the worksheets, let's discuss the many features embedded within each simulation, and I'll share some ideas for how to use these features in your classroom. So I'm going to start with that first scene, the introductory video. And this sim I'm going to show you is called the hot oven sim. And this sim highlights the relationship between temperature and thermal energy. Begins with this opening question: why does the metal in the oven burn you but the air does not? A really intriguing question to learners of all ages. Okay, so how I would use this in the classroom, I might project this big question on the screen on an overhead in my classroom. And as the students walked into class, I would prompt them as a bell ringer, bell work, to complete a quick write. So once the bell rings, prompt them, pen to paper for 3 minutes, write down anything that comes to mind in an answer to this question, hoping to kind of develop a habit of reflection and walking around and formally assessing their thinking, right? Just checking in on what their responses to this question. Then when class started, put your pencils down, and I would press play on this introductory video. So I'm going to press play now. And you can see the introductory video. I'd kind of walk students through the video in a discussion format. So I want to highlight the font size can be changed so that students can easily see it from their desks, and the video can be paused along the way. So here the introductory video is kind of pulling the students in, saying, hey, you're baking cookies, you put them in the oven, the metal burns you, but the air does not, why? And kind of drags the students into this real world setting. Now, if you come back to the sim at a later time in your lesson or in the week, you can always skip the introductory video. There's a skip option on the left-hand corner, or there's the arrow. So those are some ideas I have for the introductory video. Moving on, I'm going to show you this runaway balloon sim. And I'm going to focus on the interactive sandbox features in this sim. So the runaway balloon sim relates to the gas laws and addresses the big question: what happens to your runaway balloon when it reaches high altitude, right? It's just a heartbreaking moment for every kid, right? My 3-year-old son included, when that balloon escapes. So what happens to it? So let's press play here. And I'll skip into that interactive sandbox environment. So you can see this sandbox has sliders, a play button, and it has these responsive animations and graphs. And this is similar to every sandbox environment in all of our sim collections. So a few things to note. There are information tags that you can click by clicking on that little eye, and it'll kind of give you information about the slider. And then that gear icon has information on the graphs. You're able to zoom into the graph. And there's also a way to hide the graph, which is one of my favorite features, and I'll kind of talk about ideas I have for using that in the classroom. Now this is really cool. If you click on tutorial, we've provided like 3-minute little YouTube screencasts that introduce the concepts, kind of help students and teachers get acquainted with how to use the sim. For students who are struggling, there's kind of a way to click on the concepts that bring you back to the CK-12 modalities, a read and a video, to help them, like, let's say if they were stuck here, what's that combined gas law? Help them get acquainted with those concepts. And then for students who are ready to move on, there's challenge questions that are kind of open-ended, deep thinking questions that prompt the student to go further into that concept. All right, so just kind of a few teaching strategies, and these will also be posted in the chat window. I think it would be a great exercise to project the sandbox on a screen in class. And what I would do is I'd hide the graphs, and I'd prompt students, to get their whiteboards out, maybe work in pairs or table groups, and I would set the sliders a certain way, and then I'd challenge them. Okay, sketch what you think the graph would look like. And so I'd have them sketch the graphs, and I would drop them down. The main thing, so I want to highlight in the Sandbox, is that there are many tools available to help you easily differentiate instruction for your students. In this one interactive environment, students who are struggling are supported. They have the tutorial videos and the links to the concepts. Students who are ready to move on are challenged with those challenge me questions. And all students are prompted to just be curious, play around, and have fun. Okay, so moving on to that next scene, I'm gonna use this sim, the phases of the moon sim, to kind of go into more detail on our slider-based questions. So the phases of the moon sim that we're looking at here connects the concept of circular motion with the big question. Can you tell time just by looking at the moon? So I'm going to scroll past the introductory video and then go past that sandbox, interactive sandbox, and that'll lead me to the third scene of the slider-based questions. So if I click on a slider-based question, what's going to happen is I'm brought back into that interactive sandbox and asked to adjust the sliders a certain way to answer the question. So let's try it out. Okay, so here I'm going to adjust the slider in an attempt to answer the question, and then I'm going to press submit, and I get immediate feedback. Luckily, I got it right. Now, if I go back, my answer is recorded so I can learn from my mistakes or actually use my numbers and equations, so on and so forth, so I have access to my answers. Now, one cool thing for you teachers is that you can actually add your own slider-based questions. And it's a really nice way to kind of tailor this sim to your specific course or level. So I hope you kind of experiment with that. Now, you'll have access to user-contributed slider-based questions in our community-contributed tab. So there'll always be a way for you to distinguish CK-12 content and then user and community-contributed content, those two tabs. So just some ideas for teaching. I could envision prompting students to answer the slider-based questions in pairs during class. And I could also see the completion of slider-based questions as a homework assignment. Because I think, these would be really nice for homework because they really help support independent learning, right? They support the student in how to interact with that interactive environment and give them some guidelines. So I think a homework assignment would be great for these. Okay, so let's look at another sim and look at our final scene. This is actually a newly created chemistry sim. And the title of this sim is What's the Matter? And it opens with this awesome big question. Intriguing again, students of all ages. If ice, water, and steam are made of H2O molecules, what makes them so different from each other? Okay, so, after reading this opening question, I'll advance directly to the interactive sandbox environment. So go ahead and do that. And here in the chemistry simulation interactive sandbox, you can see it's a little bit different. There's no sliders, but there's this beautiful molecular overlay on this simple everyday scenario, right? So you have this glass of either ice, or here you have water, and then I can even adjust it to steam in a glass cup. And really the goal here is just to see the world as just molecules interacting. And I know you chemistry teachers out there have huge smiles on your faces because this is your goal. This is how you want your students to see the world. So I hope that these simulations help you in that effort. So I use this sim, I'd like to focus on this last scene, and this is in all 120 simulations, are real world examples. I love these 4 more intriguing questions that kind of provide students with paths to continue their learning, right? What is fire? So here we've gone from different states of matter to what is fire? So I think it'd be fun to prompt students to do further research on one of these examples for homework and share their findings with their classmates the next class period. Another thing that I showed you there was you can actually add your own real-world examples if you click on that plus icon. So another fun homework assignment, let's say you use the simulation in class. Students, you could prompt them, go home and add your own real-world example. I think they really get a kick out of seeing their work displayed, you know, on the CK-12 site in this international portal, and I think that it'd be really fun for students to add to our bank of community contributed content. So those are kind of two ideas I have for using those real world examples. Also, I just love the questions. I think that that there are a lot of great questions that probably you could think of labs or different classroom activities to create around these questions as well. So make sure to take a look at them. All right, so moving on, one of our main goals of these interactive simulations is to challenge common student misconceptions regarding science. That was kind of central to our creation of this collection. I created this chart because as a science teacher, right, this is your goal, to dispel these common misconceptions. And I really think that our simulations can help you in this important work. So, so here are some sims that I think can enhance your students' overall conceptual understanding of science. And I'll just kind of quickly go over the first few. The sim we just saw, What's the Matter? It would be great using that sim to dispel the common misconception that particles of solid have no motion, right? You could put it on the solid ice and see that the molecules are still jiggling and have a great class discussion around that. Also, I put there Expand and Contract sim. That's a sim that illustrates the Golden Gate Bridge and the solid molecules moving in the Golden Gate Bridge and how that motion is related to temperature. So take a look at that simulation as well. One of my favorite misconceptions, right, I always try to start the year out with dispelling this one, that mass and weight are the same thing. Take a look at the astronaut training chamber sim. I'll maybe at the end, if I have some time, show you this simulation. It's awesome. You can take an astronaut and he lifts a certain mass and you can change his location from the Earth to the Moon to Mars to even Saturn's moon Dione. It's really cool and allows students to dispel that misconception that mass and weight are the same thing. So please take a look at these and hopefully they'll help you in dispelling some of those common misconceptions. Okay, so I know you math teachers out there have been very patient, and I did want to highlight 4 sims that can help you and be used in teaching math concepts. So on the top left, we have the water fountain sim that has to do with projectile motion, and I think it can be used in a pre-calculus class to teach parametric equations where the x and y variables are dependent on a third variable. In this simulation, that third variable would be time. On the top right, there's the driverless car sim, and this is a really fun sim to teach vector addition. I think your students will really like that. On the bottom left-hand corner, we have the stadium wave sim. This could be used for a more complicated sinusoid problem and combination of functions after learning sinusoids. It's fun. You have a group of people all doing the wave. Really fun sim. And then on the bottom right-hand corner, we have the At the Crossroads sim. And it can be used to teach conversions of systems of measurement, providing students with an opportunity to practice unit conversions across systems. So like I said earlier, although we formally labeled our simulation collection as either physics or chemistry, there are so many, there's 120, and they can be used to highlight real-world applications connected to a variety of STEM concepts. So go on the browse page and check them out. I think you'll find something hopefully you can use in that first week of school. Okay, so this actually concludes my portion of the webinar. And here's just a quick review of everything I just covered. So the sim features, again, our goal was to build upon everyday examples, not laboratory models, and really just overlay the science on these real-world settings. In every sim, you'll find interactive sliders and responsive graphs and animations. You can filter these sims by NGSS standards. And the big one I'm really excited about, like you said before, is that you can download individual sims to your device for offline use on those tablet devices through our app. Some of the resources for teaching that I highlighted was those worksheets, again, downloadable to PDF, easily printable. Please check out those tutorial videos just to kind of kind of help you out with ideas of how to use the sim, get familiar with the sim. They're about 3 minutes each. And then there's links to the concepts, and there are challenge questions in each sim. Like I said, everything's here for you just to grab and go. So, you know, even if there's one of those days in class where, you know, you have a conference, you have to miss class, I could see printing out the worksheet, assigning the sim, and students have to complete those challenge questions and slider-based questions on the worksheet and turn it in by the end of class. It's just this really nice lesson, interactive, and kind of gives them this real world connection to a concept in this compelling way. So hopefully you took some teaching strategies and planning strategies that you can use. And like I said, share with us your feedback. I love hearing your ideas for how to use them in the class. And I'm excited, you know, to hear from you.
While you've been presenting, Sonia, there's been a lot of great conversations in the chat window. You've got a lot of people excited. Favorite session so far. Kids are going to love this. So lots of people are ready to put this to use. We have lots of questions in our queue too. So I'm going to start throwing some your way. But maybe we can just start, since you went right after Katie. Katie gave them a tour of the PLIX. You gave them a tour of simulations. A couple users have asked, you know, what is the difference between what you guys are demonstrating? So just, you know, you want to do a quick recap of the difference.
Sure, Lindsay. So I would say, in my mind, the main distinguishing factor between a PLIX and a sim is the PLIX is a very simple interaction. It usually involves dragging a red dot, and that shows some sort of illustrative change or numerical change. So it's very simple interaction. Where the simulations are more like this entire portal for learning. So the kid, through the student, through the introductory video, is drawn into this setting. In the interactive environment, there's multiple sliders, 2 to 4 different sliders that change variables. And then they're brought to those slider-based questions, and the final scene is the real-world, you know, additional real world connections. So the simulation, think more of like this portal for learning where the science is overlaid on a real world setting. And the PLIX is more of like a simple interaction that allows them to kind of practice application of a concept. Another distinguishing factor with the PLIX is there's about, I think she said 1,130 PLIX. They're created specifically for every branch in science and math. So they have PLIX specifically for physical science. We have PLIX specifically for chemistry, earth science, and biology, and including the math, algebra, geometry, etc. So with PLIX, if you're looking for something, an interactive that's designed specifically for your branch that you teach, and specifically for those standards created for those branches, there will be a PLIX for you. In contrast, the simulations, we started with physics. So we have 100 dedicated, you know, to physics concepts, and then about 13 for chemistry. So as of now, there are not simulations available for biology and so forth, and specific math branches like algebra. So like I said, I do think there will be some simulations that you can use in your classroom, but as far as in those branches, there'll probably be more PLIX available to you.
A couple users asked, I think when you were showing about the apps, I'm wondering specifically how these simulations play on Chromebooks. Do they need to download the app or do anything specific to use it on Chromebooks?
No, Chromebooks are just launch and go. So like I said, through the CK-12 website, ck12.org, you can hit that simulations icon on the bottom left, that little circular icon. You're taken to our browse page, click on a sim, it will load really easily. So, or if you want the shortcut, just give them the link to the Sims browse page. So on Chromebooks, it should just be one click and launch. The app is actually just for tablets, and really the main kind of benefit of the app is the ability to download the device for offline use. So that would be why you would use the app on tablets. But as far as Chromebooks, I think they work and launch very nicely on Chromebooks. So you'll be pleasantly surprised.
Okay, we still have a bunch more questions that answer, which I think probably in a minute here, it might be better for Sonia and Katie. Maybe you guys will start sharing your screen. I think we have a lot more probably Sims questions specific to, we've got some on how do you change the font sizes, how do you use the Sandbox feature. So we'll have Sonia share her screen here in a few minutes and maybe do a few of those specific tutorials there. I'd like to, just for the sake of time, as we're approaching the hour mark, continue on and get you guys your assignments and a few wrap-up information, but please keep the Q&A coming. We'll stay on, as always, to answer more questions. As for your assignment for this session, we have the tiny URL link for you here, tinyurl.com/CEP17 SimsPlix. That is your link. We're going to put it in the chat window. And then all of the assignments can be accessed on our Certified Educator page. So when you guys go to ck12.org/certified2017, that's where you find the information about the sessions. We had a lot of questions. I know you guys liked some of the teaching strategies and the common misconceptions. Those handouts, I'm not sure if they're already on this page. If they're not, we're going to get them on the page underneath the simulations and PLIX session. So if you want to download those PDFs, we will get them to you so that you can have those to start the school year and use in your classroom. This page is also where we post any of the archived videos. So today's session is being recorded. Usually takes about 24 hours or so to get it up on YouTube and on this web page, but you can see a record of any of the sessions that we've already had this summer. If some of you are joining us and you're new, you haven't been with us the past 3 weeks or so, there's really not enough sessions left to string together the 7 that you need for certification. But if you're just looking for information of kicking yourself, you wish you joined one of these sessions that's passed, the best thing to do is to come to this page and catch up, watch one of the archived webinar sessions. Again, all of the assignments, everything can be found on this page. We've appreciated all of your guys' feedback that you've sent this summer. If you have any more, this isn't a required assignment, but especially as we get toward the end, it's a great time. You can send it on a specific session or just give us some general feedback of how we've been doing and how we can make modifications to this program in the future. So your tiny URL for that is tinyurl.com/CEP2017 feedback. It's optional, but good, bad, or otherwise, we'd love to hear from you of what's working, what's not working, and how we can continue to improve. We always show you the support at CK-12.org address. Hopefully you guys are feeling supported throughout this program and that doesn't drop off. After the program ends, you're supported year-round with our support center, so send an email anytime we can help you. And then also join in on the conversation on our cafe that Katie really showed you what we've got going on in our cafe. We do have an educators cafe that you guys can join and have a discussion there. There's also some conversation happening on Facebook and Twitter. Follow us at CK12 Foundation or hashtag CK12 Foundation. So if any of you need to go, it is the hour mark. You are welcome to sign off at this point if you need to. But right now, I'm going to have Sonia go ahead and take control of the screen. And then I think we'll do a tour of some of the PLIX questions, or some of the Sims questions. If you guys want to know anything else about PLIX, Katie's here to answer questions as well.
Okay, so can everyone see my screen? Okay. So why don't I just jump on and show you one of my favorite Sims, and I think I talked about it on that Dispelling Misconceptions, about the difference between mass versus weight. So here I am on our lovely CK12.org website, our homepage. Like I said, just a quick, easy, clicking on the simulations icon, boom, will take you to that beautiful Sims browse page. So now that we're on the Sims browse page, maybe I want to look for a sim on mass versus weight. So I'm going to say mass versus weight. Okay. So here, just by the little search bar, I find our astronaut training chamber sim that highlights the concept of mass versus weight. So let me click on it to launch. Okay, so here we have that opening question. How much weight could you lift on the moon? And I think Lindsay had said that there was a question on like changing the font size. So let me play the video. And here is just like our standard font size. You see this, the top right-hand corner where I'm clicking, there's a capital A and a lowercase a. If I click on that, I have 3 options like small, medium, large. So why don't I make it large? And there you could see just, right away. And this is the same for the PLIX. So if you ever see that capital A, lowercase a, you can change the font size, which is very nice for, like I said, putting it on an overhead, like a big screen in your class, so on and so forth. So this introductory video is pulling us in. The astronauts lifting the same object on different locations. Is it easier? Is it harder? Let's look at the physics behind this. And okay, so I'm going to scroll past, and I'm now in what we've been referring to as like the sandbox, the interactive sandbox. So here you can see, and what I really love, I just want to like highlight about our simulations is that all 120 of the simulations have the same structure. So you're not wasting class time teaching students about how to use a simulation. You're just simply, they're getting familiar with it, maybe after using 1 or 2 simulations, and you can spend the time teaching the concept, not how to interact with the simulation. And that's what I really like about this kind of streamlined structure. And you'll see, I'm sure, after you use the sim in the first few weeks of school, by the 3rd week, students will be able to jump on, they'll know exactly how to interact, where to find things, and you'll never have to go back and use teaching time to teach how to use the tool. You can just focus on the concept. So here, you can adjust the mass of an object. So let's go with 500 kilograms. I believe this astronaut's very strong. And then we can have him lift it. Let's do something fun. So let's go to Mars. And you can see right there, the animations change. And that's one thing I want to show is, let's say I'm a middle school, science teacher. I don't even want to worry about the graphs or the slope of the line being the gravitational constant, stuff like that. That's for high school teachers. Here, just the animations itself can teach the student. So if it's too heavy, too massive for the astronaut to lift, he won't be able to lift it. And if he can lift it, he will. So actually the animations do respond. And so let's say we bring it back to the Earth, and you'll see here, it's, okay, I'm not there. That's good. So now maybe if we go to Saturn's moon Dione, and you can see we're learning something just by the animations here.
So a question came in about what's the difference between the sandbox feature and I think where you're doing the slider-based questions.
Sure, that's a really good question. Okay, so here we are in the sandbox, and like I said, it has usually sliders and graphs. So then if I go and click on the arrow over, that 3rd scene that I have access to is what we call the slider-based questions. These questions can be answered back in the sandbox by adjusting the sliders. So at what location is the gravitational field the weakest? If I click on that, I'm brought back to this interactive sandbox, and I'm prompted here, there's a little hint, adjust the location slider so the gravitational field is as weak as possible. And so then I can try it. So what I can do here is take the same mass and kind of change the locations and see, maybe it's the moon, maybe it's Mars, based on what I think. And here the graph gives me some numerical information. Again, all of our graphs are numerically accurate. So you could actually plug this in using the equation F equals mg. So I could plug in the force, I could plug in the mass, and solve for g, the gravitational constant. And I would actually know, then I could compare the g on Mars versus the moon versus Earth and answer the slider question that way. Or I could just experiment. So here I put it on Mars, I'm going to submit, my answer is incorrect. so I could try again. So you get that immediate feedback, my answer's recorded, and also, like I said, you can kind of solve any way you'd like, by simple trial and error, or by actually using the numbers in the graphs, plugging it into those scientific equations, and doing it that way.
So related to the graph, somebody just asked, is there a way to create a multi-line graph, or would the kids just have to record manually after each test?
Ooh, I love that question. Good question. Okay, so one thing I want to note, on the worksheets, we've actually printed these graphs for you on the worksheets. So if you wanted to print out that, even just that one page of the worksheets, we have the graphs ready for you, blank graphs, so students can jot their sketches there. However, there is one tool here. So if I click on that gear, this gear icon on the graphs is awesome. So I can actually enable last run. What that will do is allow me to compare 2 results. So if you wanted to compare more than 2, you kind of have to sketch them on, like I said, that worksheet. We have blank graphs ready for you. But if you just wanted to compare 2, so here I could see, I believe this was Mars and this is Dion, just from the linear graphs. And like I said, you could go as advanced the slope, right? We could see that the gravitational constant on Mars is much less than the gravitational constant on Dion. So at least I would know that Mars is weaker than, the gravitational constant on Mars is weaker than Saturn's moon.
Question about these different parts of the Sims. Can you move the kids through only specific parts of the Sims, or do they have to go through it all?
No, so this, like I said, everything at CK-12, I love it. It's do it your way. So we have it available, but do your thing. So the idea here is, yes, there's an opening question, and sure, you can play it and spend some time with it. Or if you just want to hop right in, like I said, you can skip it. If you start playing the video, you can skip right here on the bottom left, or just hit that kind of like little caret arrow and hop right into the sandbox. If you've already done the sandbox and you're ready to do the slider questions, go forward. If you simply as a teacher just kind of need some ideas and like compelling real world questions on this concept. So here's the concept of mass versus weight. Maybe I just need some like fun class discussion, ideas to prompt class discussions. We have these questions are awesome, and I could imagine using them in many ways in my class. So why is an astronaut weightless, right? That gets into just this like super fun question on weightlessness, and is there gravity, right, on the International Space Station? That's just like a huge misconception that there's no gravity in space. So however you want to use the sim, hop around. There's no time limit. There's no mandatory, you have to do this first before moving on. Learn it your way. That's what we're about here.
This one was kind of a comment/question, I think. So the simulations don't allow students to measure variables like PhET or direct measure videos.
Great question. So they do, as far as measuring variables, and I can kind of show you, why don't I hop in, like in this case, there are measurements on the sliders and the graphs. So you can actually see 500 kilograms and let's say here 500 kilograms was 5,000, right? So you could actually, using the equation F equals mg, like I said, measure g in a definite way. So let me just kind of bounce around. Let me show you some other examples. So here, let's say bobsled. So this is just like a fun simulation on an advanced concept. So let me look at some of the concepts here. Centripetal force problem. So here, as you can see, the speed, right? So there's a number there, like you can actually measure the turn radius, the mass. So from the sliders, from the graphs, and you can actually have the force diagram to kind of show the direction of force vectors. These can all be used in a variety of ways to address those centripetal force problems and solve for those variables. So like I said, sliders have numbers, the graphs show the relationship between those numerical variables, and all of everything is mathematically accurate, so you can use them to derive equations or plug into equations.
Okay. Another question, why only 3 questions for the sim? Is there a way to increase the questions? And then I think you already kind of talked about, are there math sims because it only shows physics and chemistry. I think you already talked about what's available, but maybe again show where the questions are and where more can be found.
Sure, it's a great question. So here I'm going to click on Journey to Mars. I love this one because kids are really interested in Mars. It's like a hot topic. It's really fun. So why do trips to Mars happen during certain launch windows? So, okay, I'll give you kind of the reasoning behind our 3 slider base. Oh, this one actually doesn't have. So some of them, if that slider is a calendar, so it's hard to do slider based questions. So let's go to Cassegrain Telescope. Have it load here, and hopefully everyone's noticing I'm loading easily with just one click. Beautiful, which is really important for these simulations. So, okay, how does a telescope collect and magnify light? So if I go into the slider-based questions, our reasoning for 3 was really the goal of this is to get a kid, a student, or a teacher. I mean, frankly, myself, right? Teachers have so much on their plate. They don't have time to go in and learn the sim and how to interact with it. So we've done this for both students and teachers. So what I would do is I would probably watch the tutorial video first, get acquainted with the sim. Then I would look at the slider-based questions, and these were created to prompt the student or teacher who's like, where do I start, right? And that's really a barrier for learning, and we don't want that. We want to remove all barriers, to learning. So the idea is for the student or teacher who's like, where do I start? We created these slider-based questions. So like I said, they just kind of are aimed to get students familiar with how to use the sim, familiar with the patterns of the variables, and familiar with how those variables are related in the concept. So adjust the sliders so I can collect the most light from the sky. And then there's like a little hint here. So before, if I'm just in this sandbox and I say, where do I start? What do I do? Through that slider-based question, I have some guidance. So my goal is to collect the most light. I can try, and then I can keep trying again until I get it right. It gives me some guidance, a prompt, and kind of a goal. Now, the big deal is if you want to add more, that's awesome. That's why we love our community, because you guys contribute. So I clicked on that. Let me just do it slowly. That plus icon says create new question. And with that, you are welcome to type in your own questions. And the parameter is that they have to be able to be answered by adjusting the sliders. That's the goal. So feel free to add. And then, like I said, our community contributed content is accessible on that tab. Now, as far as I think Lindsay's question was like, are there math? Are there biology? We get that question a lot. And I'll just give you again, just kind of like our reasoning behind this. We started with physics and our collection of physics simulations because the main goal was to kind of overlay science onto an everyday setting. We found when we talk to science teachers in our community that students have this way of like, they think scientifically in a science classroom. And then when they exit the classroom door in the hallway of the school, right, just outside the classroom, they don't think those same laws apply. And so we wanted to kind of prompt students and kind of get it in their head that science really occurs everywhere, on the practice field, in the swimming pool, as they're driving to school, and think about science and how it applies to their world, right? That's always the question for students. Why does this matter to me? So that's really was like the philosophy behind this. And the more sort of organic place to start is physics, because the whole purpose of physics is to explain our physical world with, mathematical equations and the scientific principles behind our physical world and how it works. So that's where we started with physics. And then the goal of chemistry is to explain these macroscopic things in this microscopic way. How do these molecules and atoms and electrons interact in a way that makes a light bulb light up, or like I said, makes a water boil, right? And so that's where we picked up on chemistry next. Now stay tuned. I don't know what scientific discipline or math discipline we'll go to next, but right now we are focused on our development of more chemistry simulations. But that's just kind of our philosophy behind why we started with physics and then moved on to chemistry.
Awesome. How about using simulations as an assessment? Would it be a good form?
I would say, again, I am a scientist. Experiment with it. Try it out. Let us know. right now, I see it more as like developing the skills that are necessary for science, which is to jump in, try it out, play around, change one variable, measure another. I love that you can derive equations from the graphs. Like that astronaut training chamber, you can actually derive Newton's second law from that graph. So rather than just putting F equals mg on the board, students can actually take, use y equals mx plus b, the equation for a line, and plug in, the variables of that graph and derive, F equals mg. So I would say there's a lot of ways to use the simulations, like for teaching and learning. As far as assessment goes, let's say in that concept. So why don't I bring it up, astronaut, since we're familiar with it. So what I could see is this. Let's say in class we did a lab where students used a force probe. They lifted a variety of masses. They plotted the graph, and let's say I walked them through deriving that equation, F equals mg. Okay, so we've done that in class in this really fun lab environment, and they derived the equation. I could see using the simulation like, okay, plug it in and see, does it work for Mars? Does it work for Dion? Does it work for the moon? And then they could plug in F equals mg, solve for the gravitational constants on those locations, go Google the gravitational constants on those locations, see if it works out. And that way you can assess their application of the equation in a new way. So that's one idea I have as far as like an assessment tool. But like I said, experiment with it. Let me know your ideas. But I could see maybe as a follow-up on a lab where they're like applying the equations that they derived, things like that could be used as an assessment in that way.
All right, next question for you, Sonia. If you add your own RW example, real world example, does it get saved permanently? And also, if there is some sort of incorrect info, would CK-12 be able to correct any of the sims that are posted? Because I worry that if a student creates a sim but makes a mistake or something like that, does the sim remain permanently on the sim?
All right, well, let me just tell you, Friday morning, 7 a.m., I get a coffee and I open up all the real world contributed examples for the week, and I personally review them. So so don't be worried. I publish the ones that are accurate. If they're not, I have, I work with the CK-12 support team to kind of reach out to the user like, hey, you might want to change this or that. But everything that, as far as the real world examples that are published, we do review and so on and so forth. So I personally do that. So great question. And yes, they are reviewed weekly and they can be taken down by us. And I do look at those.
All right, I'm going to give Katie the next two questions, maybe piggybacking on what you were just saying about assessments. The question is, since she's saying that sims are more of an exploration of concepts, would you say that PLIX can be used for an assessment probe?
So PLIX can really be used however you want to use them. You can take screenshots of student answers, have them submit them. You can use the class discussion to assess a student's understanding, but they really aren't designed for assessment per se. They're more designed for exploration and play. That's why PLIX, play, learn, interact, explore. And so you can track a student's completion of a PLIX and make sure that they went through all the questions. But we don't actually provide the tools for the teacher to be able to assess whether students got their questions right or wrong.
So this is a question that's been open for quite a while now. So I think it was in relation to what you were showing with the PLIX Cafe. It says it would be great to have all discussion questions linked to the cafe or allow us to assign the discussion questions to a group.
Yeah, that would be great. So as you saw, we have the math and science questions of the week. One each goes up each week, and we're making our way through all of our PLIX. And eventually, with time, you will see all of the discussion questions will link to the cafe. Right now, we're targeting the PLIX that we're assessing to be most popular at a given time based on what teachers are teaching at any time of the month. So again, let's keep up the contact. If you have a PLIX that you know you would like to have your students comment in PLIX Corner, then email us at interactives@ck12.org and we can make that happen.
A question about PLIX. Is it Flash-based?
No, PLIX are not Flash-based. I believe they're HTML5, like The Sims.
Okay. We have cleared out our questions, so we're going to give it just a couple more seconds before we sign off for this morning. Thank you all for joining us. We hope to see you later on this afternoon or in the coming days. Thank you. Bye-bye.